Alright, first lesson we're going to deal with is going to be on solving equations, and for many of you this is going to be a review. We're going to look at different kinds of equations, and we're going to start with linear, and this is the one that you already know how to do. So how do I know it's a linear equation? You'll want to fill this in. It has only one variable, and that variable is to the first power. So there's no x squares, no x square root of x, or anything like that. So how do we solve it? We're going to simplify each side of the equation separately by combining any like terms, clearing parentheses, fractions, or decimals. I call this the cleanup work. Then we're going to isolate the variable on each side. So we're going to do that by either adding or subtracting as needed to get all the variables on the same side of the equation. Then we're going to undo any addition or subtraction. Then we will undo any multiplication or division. Then we will check our answer. So that's what we're going to be working on first of all, is solving these linear equations, and we'll be following these procedures to do that. So we're going to start first of all in section 2.3 on page 124, and I have number 7 is 3x plus 2 equals 14. There is no cleanup work to be done, so what I need to do is to just subtract 2, because this is a positive 2. I need to subtract 2 from each side. When I do that, these are going to zero out, and on the right hand side I'm going to get 12, and I just copy my 3x. Now I need to undo whatever's been done to the variable, and it's being multiplied by 3. So I need to divide by 3, and I do that on both sides of the equations, dividing by 3. Here the 3's are going to divide out, and so I get my answer, x equals 4. Now, if I want to check that, I simply replace the x in the equation with what I found my answer to be, and see, do I get 14? Well, 3 times 4 is 12. And if I add 2, yes, I do get 14, so that checks my answer. So on a quiz or a test, this is how you would check your answer to see if it's right. Moving on down to number 9, we have negative 5z minus 4 equals 21. Since this is a negative 4, or a subtracting 4, I'll need to add 4 to both sides to solve the equation. So when I do, those are going to zero out. I copy my negative 5z, and I do the math to get 25. Now, what's connected to the z is this negative 5, and it's connected by multiplication, so I need to divide. So I divide both sides by negative 5. Notice that when you undo addition and subtraction, you're going to change the sign. But when you undo multiplication or division, you divide by exactly what it was. So in this case, I'm dividing by negative 5 on both sides. And when I do, these two negative 5's are going to divide out, and I'll get just z. And on this side, I'm going to get negative 5, since a positive divided by a negative is a negative. And I could check that as well if I chose to. Now, on number 11, I'm going to start by, this is the time where I don't have all my variables on the same side. So I want to move this 2p over here, and it's positive. That means I need to subtract it. And when I do that, on this side I'm going to get 2p minus 5, but on this side I'm going to get 0, because those two are going to zero out. So now I need to add 5 to both sides to undo this part. So I did that. And now I need to divide by this 2, which I did right here. And so I just get 5 over 2. And I leave my answer in that form. I don't need to change it to a mixed number. Now, I want to show you an alternate possibility for this same problem. starting with the same problem, I could have subtracted 4p from both sides. That would make this one negative 2p, and those would zero out, and that would be negative 5. Then I would divide both sides by this negative 2, and I still get 5/2 as my answer. Typically, we tend to put variables on the left and numbers on the right, but it doesn't have to be that way. And you can see in this problem, if we move the variables to the right, it does make our work a little bit shorter. So either way is acceptable. You don't have to do both, but either way will work. All right, now we're moving on down to number 15. Again, there's no cleanup work that can be done, but I need to get all my variables on the same side. So I'm going to start with subtracting this 3m from both sides of the equation. And when I do, I get a 2m plus 8 equals 7. One of the things that some of you struggled with in previous courses was remembering that this equal sign is like a barrier. Things don't cross over this equal sign unless you do something to make that happen. And so you can't just move numbers across. You've got to undo something. So the only way I can get this 3m over here is to undo that by subtracting the 3m. And so that's where I am right now. Now I'm going to subtract 8 because this is a positive 8. And when I do, those are going to zero out, and I get 2m and a positive 7 and a negative 8 is a negative 1. Now I need to divide both sides by 2. I didn't write that in, but divide both sides by 2, and I get negative 1/2 as my answer. Alright, so again, my equal sign is like a barrier. Things don't cross over unless you do something to make that happen. On this particular problem, there is some cleanup work to be done. Back up here when we were talking about our suggestions, we can combine some like terms. And if that can be done, you do that before you do anything else. So on the right-hand side, I have an 11h and a minus h. So I can combine those to get a 10h. Now notice, nothing crossed the equal sign. This was all on the same side. So nothing changed signs. I just combined those like they were. Now I want to move this. I'm sorry, I'm going to move this 10h. So now if I want to get it across the equal sign, I've got to undo it. So I'm making it a negative 10h on both sides. That gives me a 2h here, 12 minus 10. I copy the negative 5. This zeroed out, and then here's this 5 right there that I copied on the right-hand side. Now I want to move this over here because I'm going with the principle of variables on the left, numbers on the right. So I've got to add the 5 to both sides to make that zero out, and I get 2h equals 10. Then I need to divide both sides by 2, and I get h equals 5. Alright, moving on down to number 21. Again, there's some cleanup work here that we can do. This 7r and this minus 5r can be combined because they're on the same side of the equal sign. And this 5r and this minus r can be combined. So that's what I did. 7r minus 5r was this 2r, and I just copied that 2. This 5r minus r was 4r, and I copied that 2. Now I want my variables to be on the left, so I'm going to subtract 4r on both sides. That's going to give me a negative 2r, copying the 2, and copying this 2. This is the 2 that came from right there. So if it doesn't zero out, you've got to keep it there. You can't just throw it away. And here's my positive 2, so I'm going to subtract 2 from both sides. So that's zeroing out. I'll copy that, and I'll do this arithmetic. and I got negative 2r equals 0. Now I need to divide both sides by this negative 2, and 0 divided by any number is 0. So my answer for that problem is just r equals 0. And again, if you wanted to check it, you would replace 0 for the r in every place. And that would be 0 minus 0 plus 2, which is 2. And on this side, we'd have 0 plus 2 minus 0, which is also 2. So that would tell me that that checks. All right, number 25. Again, there's some cleanup work. Notice that in this possibility, clearing out parentheses is one of the first things that you want to do as well. So I'm going to distribute. I'm going to multiply. Oh, why is that not focused? Okay. I'm going to multiply this 3 times this 4x and this 3 times this 2. And when I did that, I got 12x plus 6, and I copied everything else. Okay? So again, here's my equal sign. Here's my barrier. So these two things are on the same side of the equal sign. So I can go ahead and combine them like they are. And 12 plus 5 is going to be 17. I just copied the 6, copied the 30, copied the negative x. So anything you didn't do something with has to tag along to the next line. Now I'm going to add an x to get rid of this, get all my x's on the same side. And when I do, that's going to be 18x. I'll copy the 6 and copy the 30. Now I want to subtract the 6. So I added negative 6 to both sides. I copied my 18x, that zeroed out, and I combined those to get 24. Now I'm going to divide both sides by the 18. You divide by the variable with, the number with the x, the coefficient of the x. So I'm dividing both sides by 18, and that's where I was supposed to mark something out and change it, and I forgot. So please change this on your paper. That should be 24 over 18, and you're going to divide those both by 6 and get 4 over 3 as the simplest fraction. Make sure you make that correction on your paper. Number 29. Negative 2p plus 7 equals 3 minus, and oh, I got some parentheses going on here. So I got to clean that up. Well, remember, this is like an understood negative 1. So you're going to multiply that by the 5p, and you're going to multiply it by this 1. And when you do that, you're going to get a negative 5p and a negative 1. And then everything else I just copied just like it was. Now I'm looking for opportunities to combine like terms. And I see this 3 and this negative 1. So I combined those to get 2. Everything else stayed the same. Remember, here's my barrier. You got to keep that in line. Now I'm going to add 5p to both sides. And when I do, I get 3p, I copy the 7, and I copy the 2. And this zeroed out. Now I'm going to add negative 7 to both sides. And when I do, this is going to zero out, and I get just the 3p. And on this side, I get negative 5. That was a negative 7 right there. So I get negative 5. Now I need to divide both sides by the 3. And my final answer is p equals negative 5/3. Moving on to number 35. Again, I have some parentheses here I need to clear up. So I'm going to multiply negative 5 times this x and negative 5 times this 2. And when I do, I get negative 5x and negative 10. Everything else stays the same. Now I'm going to look for opportunity to combine like terms. So I'm going to take this this 11x and this minus 5x and combine them to get 6x. Copy, copy, copy. Now I'm going to subtract this 6x because I want to get the x's off of this side from both sides. Well, when I do, not only does this zero out, but this also zeroes out. And I end up with a statement that has no variables in it. So here's the rule. If you end up with a statement with no variables, if the statement is false, then your answer is the empty set or no solution. If the statement is true, then your answer is all real numbers. That means you can use any number in the world in the equation that would make it true. Well, this statement is obviously false. Negative 10 does not equal 5. Therefore, my answer is no solution. So you want to add this maybe to your paper over here. You might want to write that in that area as a reminder. Now, number 37. Again, we got some parentheses. We've got multiple parentheses this time. So I'm going to multiply negative 4 times 7, negative 4 times negative 2t. Excuse me. I'm also going to multiply 4 times t and 4 times negative 1. Excuse me. And when I do, this is what I get. Now I'm going to look for opportunities to combine like terms. I took this 24 and this negative 28 and combined them. I just copied the 8t. And I just copied the 4t minus 4 on this side. So now I'm going to subtract the 4t from both sides to get all my variables over here. This is going to zero out. On this side, I'll just copy the negative 4 and bring it down here. On this side, I'm going to copy that negative 4, and then I'll combine those two to get 4t. So notice that when I did this minus 4t, I put my minus 4t under the t's. Write it under the variable that you, or the term rather, that you can actually combine it with. So now I'm going to add 4 to get this over here. So I added 4, and when I did, that zeroed out and that zeroed out. And I got 4t equals 0. Well, that's still okay, because I can just divide both sides by 4 and get 0 for my answer. Alright, number 39. Again, distributive property going on. 6 times 3w, 6 times 5, 2 times 10w, and 2 times 10. And when I did that multiplication, this is what I got. So now I'm going to subtract the 20w because I want to get it, the w's on the left. So I did that. That zeroes out. That's going to be a negative 2w. Copy the 30 and copy the 20. Here's my 20 that I brought down from right there. Then I'm going to subtract the 30. And when I did, I got negative 2w on this side and a negative 10 on this side. I transferred that over here because I was running out of paper. Now I'm going to divide both sides by negative 2. Negative divided by negative is positive. So my answer is going to be a positive 5. Moving on to number 43, more parentheses. So negative 1 times 4x, negative 1 times 2, negative 1 times negative 3x, and negative 1 times negative 5. And when I did all those multiplications, I got this line. Notice the right-hand side I just copied because nothing happened with it. So now I can combine some terms. I can combine this negative 4x and this 3x. I can also combine this negative 2 and this 5. And when I do, I got this line. Negative 4x plus 3x was negative x. And negative 2 plus 5 was 3. Now I'm going to subtract 3 from both sides. And when I do, this is going to zero out. This actually zeroes out as well. I copied my negative x. Now you can't leave a negative sign with the x. So you can think of it as changing the sign on both sides, or you can think of it as dividing by a negative 1. But 0 divided by anything is still going to be 0. So that really didn't change my answer, but it did get rid of the negative sign. On number 47, more multiplication. 6 times 4x, 6 times negative 1, 12 times 2x, and 12 times 3. And this is what I got when I did those multiplications. Now I'm going to subtract the 24x to move my variables to the left. And when I do, it zeroes out on both sides, so I'm left with a statement that has no variables in it. And as we said before, if this statement is false, then my answer is no solution or the empty set. Alright, let's look at number 49. More multiplication. 4 times x, 4 times 8, 2 times 2x, and 2 times 6. Now this 20 is not going to be affected by that multiplication, so it's just going to tag along. So here's what I got after I did the multiplication and then brought down the 20. Now I'm going to combine like terms, so I'm going to combine this 12 and this 20 to get 32, and everything else stayed the same. I didn't change anything else. Now I'm going to subtract this 4x to move my variables over there, and when I do, my variables zero out on both sides and I get 32 equals 32. Well, certainly that's a true statement. So my answer is all real numbers, or it could be written as negative infinity to positive infinity. That's how we write all real numbers in interval notation. So either one of those formats would be right for expressing that answer. That finishes my examples for section 2.3, so you should be ready now to do the homework for 2.3.